Today, our intent is to go through as many of the remaining review questions and practice problems as we can. And the reason why I have you look at the EPPs is hopefully you will either have a chance to try another problem that you just did not get from the assignment. You'll have another chance to try it again. To not just know that you did it wrong, but to see a way to do it right. And today, by reviewing what you've already done, hopefully you can see why what you did was, this is one of those weird classes, remember? What you did was not wrong, but it wasn't correct. And a lot of it has to do with significant figures and precision and things like that. So we are going to pick up with review question number 11. Notice in review question number 11, and I'm not going to necessarily read every one of them, but the question doesn't ask you to do any mathematical computation on the coefficients, right? It's not asking you what is the number answer. All it's asking you is what is the unit answer to this question. It's written 4 centimeters plus 2 centimeters equal what? And the question is, what are the units? Now, if you sit here and go 8 plus 2, well, that's 10. So it's going to be 10 Smurfs. Well, that's awesome. You know it's 10 Smurfs. But it's not Smurfs, right? It's 8 centimeters plus 2 centimeters equals 10 centimeters, right? If you were doing algebra, you would say 8y plus 2y equals 10y. So if you're making the analogy of units to algebra, the units are the variables, the numbers are the coefficients, the actual integers in the formula. So centimeters plus centimeters are going to be the units of centimeters. Any question on that? That should be pretty straightforward. 2 eggs plus 2 eggs is 4 eggs. Not 2 eggs plus 2 eggs is 4 eggs squared, right? That's multiplication, right? 8 centimeters times 2 centimeters would be 16 centimeters squared, because you multiply the coefficients and then you multiply the units. Centimeters times centimeters is centimeters squared, just like x times x would be x squared. The second one asks if 4 grams divided by 2 milliliters. And the units there are grams per milliliter, right? It's right here on the board. Grams divided by milliliters. The units are grams per milliliter. And that is known as a derived unit. So which of those is derived? The second one. The grams per milliliter is derived. In other words, the units came about, the units were created because of a mathematical operation. Centimeters plus centimeters gives me centimeters. Did I create something new? No. I took centimeters and centimeters, right? Grams divided by milliliters equals grams per milliliter. The grams per milliliter is not an organic unit. It's something that came about because we did the math of division. We had an operation of division which created a unit known as a gram per milliliter. Okay? So that's how the derived unit came to be. Okay, so if you go back to your system, in this case the metric system, you go through mass, volume, time, distance, all those core units. Other units other than that are generally going to be some kind of derived unit, some combination, some mathematical operation among those units. In this case, mass divided by volume, grams per milliliter is the derived unit. Right? I'm not going to say any questions. I'm just going to pause before I hit the advanced slides. So if you've got questions on the stuff I covered, let me know, because I think the practice problems are going to be a lot more fun than these review questions. And I do think they're fun, so yeah, if that's weird, then yeah, I'm weird. What are the 2 basic rules of scientific notation? And again, you're free to speak in here. If it gets too much, I'll ask for hands, but until then, go and help me out. Somebody give me, what's one of the basic rules for scientific notation? Ma'am? Place one digit, not the zero. Now, the assumption there is that we're going from decimal to scientific notation, right? It says only one digit in front of the decimal point, and you added the statement non-zero digit, and that's true. When you're going from a decimal form to scientific notation, you don't have a leading zero before the decimal point. However, going from scientific notation to decimal form, you have to have a leading digit, and if necessary, you need to add the zero. So some of you didn't get that. If you wrote down 0.003, that's not right. 0.003 is if you're writing from scientific to decimal. So you can add a 0 before the decimal point if you're going from scientific notation to the decimal format. But if you're in decimal format and you're writing it in scientific notation, your first digit has to be a non-zero digit. And that's what that first rule communicates. Okay? And the second one was only sig figs go in front of the multiplication sign. Not only should it say only sig figs, but it also is all sig figs, right? A lot of you still like to drop the zeros, thinking that zeros, trailing zeros right at the decimal point don't matter. They do. If they're significant in the decimal form, they have to remain in the scientific notation, even if it's a string of trailing zeros. They have to be there, because you've just eliminated a whole bunch of information. You've made your answer less correct by getting rid of trailing zeros. So, if you're going from decimal to scientific notation, only one digit in front of the decimal point, it's a non-zero digit, and only and all sig figs are in front of the multiplication sign. Survey says, here we go. 14, which is colder? Yeah, neither. So the answer is both or none? Neither. Which is colder? Are they both colder, or is neither colder? Because some people wrote both. It's not both, it's neither. Which is colder? They're both colder. It's an ongoing cycle. They keep getting colder and colder, so eventually, wait a minute, temperature's not changing. How can that be? Anyway, neither. They're the same. Practice problems, yes. Yes, now we get to some fun stuff. I'm going to kind of reduce the problem down to a very brief statement. So if you need to see the full statement, it's in the book. What does practice problem number 1 come down to? We're converting 2.4 milliliters into liters. So in this, because of time, I'm not going to go through and write down what we're given, what we're looking for. I'm going to give you the core things that hopefully by now you recognize you need in order to solve the problem. And the first thing is a statement of equality, right? What do I need to relate to solve this problem? What am I going from and to? What are the languages that I'm translating from and to? Ma'am? Milliliters and liters. I'm translating from milliliters into the language of liters. I'm going from to the other, from one to the other. And they're both part of my system, right? My standard system, part of the definitions within that system. So 1 milliliter is equal to, by definition, is equal to 1/1000th of a liter. So from that I can create what? A conversion factor. And I'm either going to have a conversion factor that has 1 milliliter over 1/1000th of a liter, or 1 liter over, or excuse me, 1/1000th of a liter over 1 milliliter. What's my form going to be in? Which way? Liters on top or milliliters on top? Pardon? Liters on top, because I'm translating into that language. I want liters in the end, therefore the liters has to be in the numerator. The other way to think of it is milliliters has to be in the denominator. Why? Because I'm trying to get rid of milliliters. Okay. So the conversion factor looks like this. I start with 2.4 milliliters times the conversion factor of liters per milliliter, so that milliliters cancel milliliters and I'm left with liters in my numerator. Do you see that? Do you see that milliliters cancels milliliters? They cancel each other out mathematically. So if I'm trying to derive a unit, I'm kind of foiled there because milliliters cancels milliliters. All I'm left with is liters. That's a standard unit. So I haven't derived a new unit. I'm just translation into another unit, converting it into another unit. Now, when I actually do the math, if I sat there and punched it in my calculator, this is probably what you would find, right? Now I ask a question. Is that the correct answer? Is it in the correct form? Why is it correct? See, it's not just simple, why is it incorrect, but why is it correct? Ma'am? Mm-hmm. Right. The answer should be to 2 significant figures. How many significant figures are here? 2. The 2 and the 4. Remember, leading zeros are not significant. Even if they're to the right of the decimal point, if they're leading the first non-zero digit, they're not significant. So there are two significant figures in this answer. How many do I have to have? Two. Why do I have to have two significant figures in my answer? Why do I have to have two sig figs in the answer? Why can't I have 3, 4, 5, 6, 1? Yes, ma'am. I'm given 2.4 milliliters. The 2.4, that number has two significant figures. Everything else I do is by definition, therefore it's not going to affect my number of significant figures. I don't have to look back here and go, okay, wait a minute. There's one significant figure here, there's one significant figure here, and I know in multiplication it's the same as the least, so therefore it's only 1. No, because this is by definition, it doesn't impact my sig fig calculation. Okay? So my original measurement had two significant figures, so my answer has to have two significant figures. And this is when you're using something where the conversion factor is a by definition. It doesn't affect. So the answer is 0.0024 liters. This came up, not on this question, but a couple of you, your math went awry, it went wrong, because you used a lowercase l, not on this problem, but another problem, but I'm thinking about it, so I want to mention it now. You used a lowercase l for liter, and then when you did the math forward, you carried it as a 1 digit in your math. That's why you don't use a lowercase l for liters. Write an uppercase L so you don't confuse it for the number 1 when you're on your calculator. Okay? Use an uppercase L to avoid that problem. Practice problem number 2. Converting 69.00 kilometers, also known as kilometers, into meters. I assume that I'm going to need a statement of equality to provide me with a conversion factor. Good. Good. I'm going to relate two units of measure. Somehow I have to relate what to what? Kilometers to meters. And I know that 1 kilometer is equal to 1,000 meters. So I can create a conversion factor from this. Either 1 kilometer per 1,000 meters or 1,000 meters per kilometer. I'm going into the language of meters, so my numerator is going to be meters, which is why it looks like this. When I do the math, I get 69,000 meters. Okay. Is that correct? Mathematically, when I punch it in the calculator, does my calculator give me that? Do I know more than my calculator? Yes, you do. You're savvy enough to go, wait a minute, my answer has to be to 4 significant figures. Why? Because my original number was given to me to 4 significant figures. 69.00. Which of those are significant? The 6 is significant, the 9 is significant, trailing zeros right at the decimal place are significant. I have 4 significant figures. My answer has to be to 4 significant figures. How do I write 69,000 to 4 significant figures? How many significant figures are in this number right now? 2, right. There are 2 significant figures. How do I get 4 out of it? Now some people want to go ahead and just say, you know what? Whenever it's a whole number like that, I should just add a decimal point and a 0. If you add a decimal point and a 0 to that, how many sig figs did you have? Try again. 6. So 69,000.0 is 6 significant figures. That's wrong. So 2 is wrong, 6 is wrong. I'm stuck. What can I do? Scientific notation. I'll write this as 6.900. I put the 2 zeros in there because I have to have 4 significant figures. If I needed 5 significant figures, what would I put in there? 6.9000. And if I needed 6, 6.90000. I will add zeros so that every significant figure is represented in the portion of the scientific notation prior to the multiplication sign. Okay? So here's a situation where my answer on the calculator says 69,000 meters, but I know better. It has to be to 4 significant figures because I was given a number in 4 significant figures, and everything I did to it was by definition. So I can't change how many significant figures my answer has to be, which is why it has to be 6.900 times 10 to the 4th. That's correct. This is true but not accurate. This is true but not correct. Let me put it that way, because now we're in accuracy and precision. I don't want to mess you up with that. This is true, but it's not correct. This is true and correct. Right? So scientific notation gives you the ability to make zeros significant. These zeros are not significant. If I add a decimal zero, now I've added 4 significant figures to the way that number looks. I can't do that. So scientific notation, more than just making it easier for you to write long numbers with lots of zeros in it, allows you to give the appropriate significance to the digits when you write them. Okay. Any questions on practice problem number 2? The math and the setup is not hard. The sig fig thing is what's, hopefully right now you're sitting there going, oh. If there are any light bulbs going on, like people going, oh, I'm getting it now. Okay, so we want to get it before the exam, right? Not pull a Meredith and get it 2 weeks after the exam. It's a last name, not a first name. Okay. Sorry, YouTube. Okay, practice problem number 3. I summarize this as convert 0.091 kilograms into centigrams. Statements of equality from which I will get conversion factors. 1 kilogram is 1,000 grams. But are we looking for grams? No. I'm going to use grams as my intermediary unit. Because we're working with conversion within a system, normally going to the base unit is the best bet. Go from a unit to the base, and then from the base to the second unit. So we need something that's going to take us now from grams to centigrams, and that is 1 centigram is equal to 100 grams. So from this, I can daisy chain or put in series 2 conversion factors to convert 0.091 kilograms into centigrams, and it looks like that. So 1,000 grams per kilogram, and then a centigram per 100 grams. You can see that kilograms cancels kilograms, grams cancels grams, and I'm left with centigrams as my unit. Since I'm looking for centigrams, and that's what the units give me, if I set it up right with the numbers, I just do the math. Yes, sir?
I had a question.
Mm-hmm.
If you, since centigrams is 0.01, could you move the decimal place over in kilograms and say, like, there's 10 centigrams in 1 kilogram? Or would that work?
That would be true, but you're not using an intermediary unit, and I would do that maybe. I would just caution you not to. If you can keep that straight, it would be right, but we're just learning basics now. So that would be a 1-step transformation. 10 centigrams is 1 kilogram. So that would be one statement of equality that would get you from the 1 unit to the final unit. Mm-hmm.
This could be a dumb question, but for the
They make me chuckle, so that's fine.
The 100 gram, why is it 100 and not 0.01?
Well, it's going to be by definition, so it's not going to affect sig figs anyway. But you said, why isn't it 100.01?
No, 0.01. I don't know.
It would be 1 gram is equal to 0.01 centigrams. Centa,
I'm sorry.
because centa is 100, not 100th.
Oh. I'm sorry, just forget it. Go on.
No, let me that's fine. Milligram
Just forget it.
No, that's fine.
I wanted to
Mm-hmm.
I'm
Well, you know what? I'm human.
here.
And also, even when I do it and I check my answers of the book, sometimes if the book is wrong and I made it the same error, it could be wrong. What should that be? Do you agree with her or with me? Okay, so this slide is wrong.
Kind of what I was thinking. That's why I said I could move the decimal point over
Yep.
for mine.
Okay. No, that's fine. Yeah.
Right?
You were right. Yes, you were right. The slide is wrong. Don't cry. It's okay.
I understand chemistry.
No, you don't. You understand. Never mind. Okay, so good catch. Good catch. It's not 100 grams. It's 1/100th of a gram, right?
Thank you.
Well, that's fine. So now if I carried the error forward, right? If I get this answer, but what should it really be? I'm off. If that's true, then I'm off by a factor of 4. Because rather than multiplying it by 100, I have to divide it by 100, which is a factor of 4, which means rather than 9,100, it should be 0.91.
So would you just put 0.01 instead of the 100 in that equation?
The last conversion factor would be 1 centigram over 0.01 grams. Yeah. But this is still true too, though. Pardon? I know you were, but when you're in class, you're talking to me, even if you're talking to somebody else. Right? Okay. Just
So was the final answer that? Or was it different?
this math, then, it should probably turn out to be 0.9100 centigrams. But how many sig figs? The answer should be 2 sig figs because there are 2 sig figs in my given. So that would mean, and again, I'm doing this in my head, but that means the answer should be 0.91 centigrams, if that's true. Because with the conversion factor being off by a factor of 4, I need to move my decimal place. If that math is right based upon what's written, then moving the decimal place 4 places to the left, factor of 4, would be 0.9100. But limiting it to 2 sig figs would be 0.91. Okay? Yep. And I'll go back and make sure go back and look at the answer key and find out why I made the mistake or why we both made the mistake. Yes, ma'am.
Okay, so what was the final answer for that one?
I'm assuming, based upon doing the math in my head on the fly, that it would be 0.91 centigrams. Is that what calculator says too? 0.91 centigrams?
Are we allowed to use our calculators on the test?
You better.
I'm sorry.
No, either that or a slide rule.
When I divided it by 100, I got 0.91, but then when I divided by 0.01, I got that answer.
That's what I got too.
So when I divided by the 100, I got 0.91. But when I divided it by the other, I got...
Okay, so
Yeah.
my conversion factor is wrong, but my final answer is right. So 9,100 centigrams is right. What I messed up was typing in the conversion factor wrong, but actually doing the math correctly. Okay, so this is a typo, not a logic issue. Okay. So then it's probably my fault on the way I typed it, not the book's answer, the way they worked it out. So if that math, if the correct math works out to be 9,100 centigrams, is that right? Yes, it would be right, because 2 sig figs and 9,100 centigrams is 2 sig figs. Right? I don't have to put it in scientific notation. Now I could. I could put it as 9.1 times 10 to the third centigrams. But if I do that, I can't put 9.100 because that would be too many sig figs. It can only have 2 sig figs. So it has to be 9.1. You see that? That this one only has 2 significant figures because the trailing zeros are to the left of the decimal place, the implied decimal place, because there is no decimal place. It's implied. And if I stick a decimal zero on there, I've now made it 5 significant figures. And I don't have the authority to do that. Okay. That's why it gets confusing sometimes when you're writing a sentence and you end with a number and you put the period in there, but the period looks like a decimal point. It's not a decimal point, it's a period. Our systems are so messed up. So anyway, we have time for one more. If we're good here, I'll go back and fix that slide. I'll try to do an overlay on the video, and here we go. Convert 69.2 milliliters into kiloliters. I'm going to have statements of equality that move me from milliliters to kiloliters. And if we follow the process I've been encouraging you, we're going to go through the intermediary step of conversion to liters, right? So a milliliter is 1/1000th of a liter, and a kiloliter is 1,000 liters. So I need to start my conversion with liters over milliliters and then kiloliters over liters, and it looks something like that. Now, if I set up the math right, when I plug it into the calculator, I get an answer that looks like this. So then I ask the question, calculator says this, I'm smarter than the calculator, is that right or not? So because the operations we're using are multiplication, we would be looking at sig figs, not precision. And since the only thing we're doing is multiplying by definitions, my significant figures of my answer have to be the same as the significant figures of my given. In this case, it's 3 significant figures because 69.2 is to 3 significant figures. So my answer has to be to 3 sig figs. How many are represented in that number as it's written? 3. So it's right. But you could also write it as 6.92 times 10 to the negative 5th kiloliters. Because there's 3 sig figs. Because every sig fig is in front of the multiplication sign. So I can see that there's 3. I can see which 3 they are. So I take this number, 1, 2, 3, 4, 5. I moved it to the right 5, so I get a negative 5 exponent. And it's 6.92 times 10 to the negative 5th kiloliters. We'll pick it up on practice problem number 5. Look at the rest of the practice problems. Go through and look at them to see if you followed the rule of sig figs in your answers and try to get the right answers. Some of you I wrote it down. Some of you I just marked it saying, you know, this is wrong. If you didn't show work, try to show some work for yourself, not for me. Make sure you get it. We'll finish practice problems, and time permitting, we'll do your questions on EPPs as the final review before Friday's exam.